Hi, welcome to another video. So, I have talked about my AI coding workflow a few times on this channel, but the workflow has changed again, and honestly, this version is probably the cleanest one I have used so far. Previously, my workflow used to be a mix of a lot of different tools. One tool for design, one tool for coding, another tool for API credits, then another place to deploy, and then I would have to keep checking which model is working, which provider is down, which API key has balance left, and so on. That works, but it also gets annoying very quickly. So now, the workflow that I'm using is a bit more streamlined. I start with design in OpenDesign, then I take that into OpenCode, then I use Requesty as the model router and credit layer, and then for the final app, I usually deploy it somewhere like Railway. And the reason I like this workflow is that it is not really tied to one single AI company. So if one model is good for design understanding, I can use that. If another model is better for backend implementation, I can use that. If one provider is down, I can fall back to another one. And if I want to switch from something like GLM 5.2 to GPT-5.5 for a specific part of the work, I can just do that without rebuilding my whole setup. So let's get right into it. The first part of my workflow is design. And this is something that I think a lot of people still skip. But if you skip design, you usually end up with the same generic AI-generated UI that everyone gets. The app works, but it looks like every other AI app. Same cards, same huge gradients, same random dashboard layout, same spacing issues, same hero section, with some vague text. So these days, before I even open the coding agent, I start with OpenDesign. What I like about OpenDesign is that I can use it to think through the interface before I ask the coding agent to implement anything. I can create the layout, decide what the main screens should look like, decide what information matters, and basically create a visual direction for the project. This is important because AI coding agents are really good when you give them constraints. If you just say, build me a SaaS dashboard, it will build something. But if you give it a proper design and you say, implement this layout, keep the navigation like this, make the empty states look like this, and use this hierarchy, then the output is just way better. So the first step for me is usually opening OpenDesign and designing the core screens. I don't always design every single page. That would be overkill for many projects. But I do like to design the important screens. For example, if I'm building a SaaS app, I will design the dashboard, the settings page, the main create flow, and maybe one or two important detail pages. Once I have that, I can export or copy the design context, screenshots, or whatever I need, and then I take it into OpenCode. Now, let's talk about OpenCode. OpenCode is what I use as the main terminal coding agent in this workflow. I like it because it is fast, flexible, and it doesn't force me into one model or one provider. That matters a lot, because the reality is that there is no single best model for everything. Some models are great at front-end, some models are better at back-end, some are good at debugging, some are cheaper and good enough for repetitive tasks, some are very expensive but useful when you need a really strong pass-on architecture or refactoring. So in OpenCode, I can use different models for different parts of the work. For example, after I have my design from OpenDesign, I can give OpenCode the design context and ask it to implement the front-end first. I will usually ask it to set up the layout, create the pages, wire up the components, and make sure that the UI actually matches the design. This is where having the design first helps a lot, because now the agent is not inventing the whole product from scratch. It has a target, it knows what it is supposed to build, it can focus on implementation rather than trying to be a designer, product manager, front-end engineer, back-end engineer, and DevOps engineer all at the same time. And that is where a lot of AI coding workflows go wrong. People ask the AI to do everything in one prompt, and then they get something that is kind of okay, but not really production ready. My workflow is more staged. First, I design, then I implement the front end, then I implement the back end, then I connect everything, then I test, then I deploy. It sounds simple, but this separation makes the output much better. Now, for the back end, this is where I usually start using stronger coding models like GLM 5.2 or GPT-5.5. And again, I'm saying models like these because the exact model that I use can change some weeks. GLM is performing really well. Some weeks, GPT is better for a certain backend task. Sometimes a cheaper model is enough. Sometimes I want a stronger model because the backend logic is important. So let's say I'm building something with authentication, database tables, payments, background jobs, and a few API routes. For that, I don't want the cheapest random model blindly touching everything. I will usually ask OpenCode to first inspect the code base, understand the stack, and then create the backend plan. Then I will use a stronger model to implement it step by step. For example, I might use GLM 5.2 to create the initial backend structure because it is quite good at coding and usually gives pretty practical implementations. Then If I want a second pass or a more careful review, I might use GPT 5.5 to check the architecture, look for edge cases, and clean up the API structure. This is also where OpenCode is nice, because I can keep the workflow in the terminal and just keep moving. I don't need to jump between 5 different apps. I can ask it to implement the database schema, then ask it to add the API route, then ask it to connect the front-end form to that route, then ask it to write tests, and then ask it to run the app and fix whatever breaks. Now, the important layer in the middle of all of this is Requesty. So Requesty is basically what I use as the model router and credit management layer. And this is one of the biggest quality of life improvements in the whole workflow. Because if you use AI coding tools a lot, you know how annoying the credit situation can get. You have credits in one provider, a subscription in another provider, an API key somewhere else, then another model is only available through some other gateway, and then suddenly one of them is down or rate limited. It becomes a mess. With Requesty, I can keep my credits in one place and use that across the tools that support it. So instead of managing 10 different balances and 10 different dashboards, I can just use Requesty as the layer between my coding tools and the model providers. That alone is already useful. But the bigger thing is the policy system. So Requesty has routing policies, and this is where it becomes really useful for coding. For example, I can create a policy where my main model is GLM 5.2, but if GLM is slow, down, rate limited, or just not responding properly, it can fall back to another model. That might be GPT 5.5 or another good coding model, depending on what I'm doing. And from the coding agent side, I don't have to keep manually changing the model every single time. I can just point OpenCode to the Requesty policy and continue working. This is really important because when you're in the middle of building something, you don't want the entire workflow to stop because one provider is having issues. That happens all the time. A model gets overloaded, a provider has downtime, the API starts returning errors, a model becomes slow for a few hours, or maybe it is just rate limited because everyone is using it. If you are connected directly to that provider, your workflow just stops. But if you're using a policy with fallback, then your work can keep going. It might switch to another model, it might cost a bit more, it might be slightly different in style, but the important thing is that you're not blocked. And Requesty also has load balancing, which is useful if you want to distribute requests instead of hammering one provider all the time. This is especially useful when you're doing heavier coding sessions. For example, if I have OpenCode doing a lot of backend work and I also have another agent doing tests or documentation, I don't necessarily want every request to go to the same provider if that provider is already slow with policies. You can set things up so the traffic is balanced or routed in a smarter way. This is the kind of thing that sounds boring until the day your provider goes down and you still need to ship something. Then it becomes chef's kiss. Now, the way I usually set it up is pretty simple. I create one Requesty key, connect that to OpenCode, and then create policies for different kinds of work. One policy might be for general coding, one might be for back-end heavy tasks, one might be for cheap tasks like rewriting docs or small refactors, and one might be for high-quality review where I want the strongest model available. So, instead of thinking, okay, which model should I manually pick every time? I can think in terms of work types: front-end implementation, back-end implementation, debugging, review, cheap background tasks. That is a much nicer way to work. And again, because the credits are centralized, it is easier to understand what I'm spending. This is a big deal because AI coding can get expensive very quickly if you're not watching it. You might think you're doing a small change, but the agent reads half the codebase, writes a bunch of files, runs tests, gets an error, tries again, and suddenly that one simple task used a lot more tokens than expected. So being able to track spend in one place is just better. Now, let's talk about the actual project flow. Let's say I want to build a small SaaS app. First, I start in OpenDesign and design the important screens. I decide the layout, spacing, components, navigation, and the general visual direction. Then I open the project in OpenCode. I give OpenCode the design context and ask it to implement the front end first. I usually tell it to focus only on the UI and not touch the backend yet. Once the UI is in a decent place, I ask it to create a backend plan. This is important. I don't just say, implement the backend. I ask it to explain the data model, the API routes, the auth flow, and the edge cases. Then I review that plan. If something looks weird, I fix it before the agent writes code. After that, I let it implement the backend in smaller chunks. So first the schema, then the API route, then the service layer or server functions, then the front-end connection, then validation, then tests. This way, if something breaks, I know where it broke. If you ask the agent to build the whole app in one giant step, debugging becomes annoying because you don't know which part is broken. But if you build it in stages, then you can keep it under control. For backend implementation, I might start with GLM 5.2 because it is usually a strong coding model and works well for implementation. Then for review, edge cases, or more complex backend logic, I might switch with GPT 5.5 or use a Requesty policy that can route between them. This is also helpful because some models are better at writing code, while others are better at reviewing and explaining trade-offs. So, I don't treat one model like it has to do everything. I use the right model for the right job. Now, after the app is working locally, I usually deploy it somewhere like Railway. Railway is nice because it makes hosting relatively simple. You connect your GitHub repo, set up your environment variables, pick the service, and deploy. If you're using a database or background worker, you can also set that up there. For a lot of the stuff I build, Railway is good enough and quick enough. It is not always the cheapest option for everything, and if you are building something huge, you might want a more custom setup. But for shipping projects quickly, testing ideas, and getting something live, it is really good. So the full flow is basically this. Design the app in OpenDesign, implement the front end in OpenCode. Use Requesty to access models like GLM 5.2 and GPT 5.5 without managing credits everywhere. Use Requesty policies for fallback, load balancing, and keeping the work moving when a provider has issues. Use stronger models for backend logic, reviews, and important changes. Then deploy the final app to Railway. That is the workflow. And honestly, I like this a lot because it keeps me flexible. I'm not locked into one model. I'm not locked into one provider. I am not constantly jumping between a bunch of billing dashboards, and I'm not depending on one company staying online every single time I want to build something. The other thing I like is that the workflow scale. If I'm building something small, I can keep it simple. OpenDesign, OpenCode, one Requesty policy, Railway, done. If I'm building something more serious, I can create multiple policies, use different models for different agents, add stricter backend review, run tests, and then deploy only after everything passes. So it works for both small vibe coding projects and more serious apps. Now, there are some downsides. You still need to review the code. Please don't just let the agent build the backend, deploy it, and assume everything is fine. Especially if you are dealing with payments, auth, user data, file uploads, or anything that touches production, you need to actually review it. AI coding tools are getting really good, but they still make mistakes. They can forget validation. They can expose something they shouldn't. They can create a database query that works for 10 users but falls apart for 10,000 users. They can also overcomplicate things for no reason, so I still stay in the loop. The workflow is not about replacing judgment. It is about removing the boring parts and making the actual building process faster. And in that sense, this setup has been really good for me. OpenDesign gives me better UI direction. OpenCode gives me a flexible coding agent. Requesty gives me one place for credits, models, routing, fallback, and load balancing. And Railway gives me a fast way to get the app live. So, this is what I'm using right now. If you're building with AI, I would really recommend trying this kind of layered workflow instead of just opening one chat window and asking it to build everything. Start with design, then code in stages, use different models for different tasks, keep your model access and credits organized, and deploy only after you have tested it properly. Overall, it's pretty cool. Anyway, let me know your thoughts in the comments. If you liked this video, consider donating through the Super Thanks option or becoming a member by clicking the Join button. Also, give this video a thumbs up and subscribe to my channel. I'll see you in the next one. Until then, bye.